All right, today we're going to do a lesson on Carnegie Learning. So you will have the link in your assignment on Google Classroom. And we're going to be looking at lesson 3 right here, composing and decomposing numbers. But before we do that, I just wanted to revisit this. You do have a video right here. It's available at all times for you. So you would just click the open. And what it does is it will summarize the key concepts of what we do today. So if you get stuck or you need some clarification on something, you can always go to that video. So you're going to go ahead. I'm going to assign this to you. So you're going to, when we open it up, you're going to be following along with me just like any other time. I will have some time where you will pause and complete some independent work, but majority of it we're going to do together. So this is our last lesson that we're going to be doing. So we'll do a lesson today, and then we'll do an assignment, and then we're going to do a quick little overview assessment to kind of see how we did with the lesson 1, 2, and 3, and then we'll be finishing up. Just a reminder, all work is due on Friday, so if you are missing anything, Friday is the last day that I can accept grades because I do have to get those grades to your teachers. So with composing and decomposing numbers, we're going to be focusing on least common multiple and greatest common factor. So what I want you to do is, this is just prime factorization. I would like you to go ahead and pause, and you are going to write the prime factorization of each number. Best thing to do is to make factor trees of all of these, and then write your prime factorization. And remember, we want to use that the exponents, put it in exponential form. So go ahead and pause right now and complete the 4 warm-ups. And then when you're finished, you can unpause to check your answers. So we're going to go ahead and we're going to do a factor tree first for 21. So I'm going to go over here. I'm going to do 21, and I'm going to think about 2 factors that I can multiply together to get to 21. And I know that 3 and 7 are 2 numbers that I can multiply to get to 21. 3 is prime and 7 is prime. So that's it. I'm done. So I know that my prime factorization of 21 is going to be 3 times 7. And I'm going to do factor trees for all of these, and then I'll go ahead and change to my cursor and write back into it. So I like to circle those prime factorization or prime numbers just so I can remember. So now we're going to go ahead and we're going to do 30. So I can think of 2 numbers, and again, your numbers may not have been the same. You could do 30 and 10, you could have done 5 and 6, but I'm going to go ahead and do 10 times 3. 3 is prime, so I'm going to go ahead and circle it, but I know that 10 is composite, so I'm going to do 2 times 5. Now 2 and 5 are prime, so we're done. Our goal is to find those factors all the way until we get prime numbers. And then I'm going to do 42 over here. So for 42, I'm going to go ahead and do 2 and 21 because 2 times 21 is 42. You may have done something different. 2 is prime, and then I'm going to do 3 times 7, and 3 and 7 are both prime. And then the last one is 19, and 19 is actually a prime number, so the only factors of 19 are 19 and 1. So I'm going to go back to this so that I can go ahead and type my answers in here, and you're going to do this too. You should have already done this, but you can check your answers and go ahead and fix them if you need to. So for 21, I have 3 times 7. So 3, and then remember we use this button right here, and I'm going to use the dot for multiplication, and then I have 7. And then for B, I have 2 times 3 times 5. So 2 times 3 times 5. For C, which was 42, I have 2 times 3 times 7. So 2 times 3 times 7. And then the last one is just going to be 1 times 19. Okay, and then once you finish those, you can go ahead and click next. Let me go ahead and delete my drawings up here so that we can see. So today our learning goals are to determine the greatest common factor of 2 whole numbers less than or equal to 100. and to determine the least common multiple of two whole numbers less than or equal to 12. So we're going to take that greatest common factor that we worked with last week and least common multiple, and we're going to apply it. We're actually going to have word problems that are going to lead us into determining if we're going to find the least common multiple or the greatest common factor. So number relationships, this is our essential statement or question. Number relationships are useful in solving everyday problems and mental arithmetic. So understanding these relationships will deepen your knowledge of how the number system is structured. And we're going to be talking about the least common multiple and greatest common factor. So the question that we want to answer today is, how can you use least common multiple and greatest common factor to decompose and compose numbers? So we have that in common. So again, we can solve real world problems that involve common factors or common multiples by thinking about the question that we're trying to answer. So for this first question, determine whether you would use either common factor or common multiple. Okay, so we did common factors, the greatest common factor, when we did the factor trees, and then we put them into the table. And then we found the common factors and then multiplied them to find the greatest common factor. Multiples, we went ahead and we counted by the number. So if we were talking about 2, the multiples of 2 would be 2, 4, 6, 8, 10, and so on. So those are multiples. And then we found the one that it had in common, and we wanted to find the least. So you are going to determine whether you'd use common factor or common multiple and then explain it. So we have hot dogs, and they come in packs of 8, and hot dog buns come in packs of 6. What is the least number of hot dog packs that you can buy if you want to have the same number of hot dog buns? Well, it's talking about the least number. So in that case, least common multiple is what comes to my mind. So I'm going to go ahead and put here, I would use a common multiple since the problem is about when the two different quantities of items will have the same amount. So we're talking about hot dogs and hot dog buns. So we would use the common multiple because the problem is referring to, I misspelled that, sorry guys, is referring to two different quantities, but we want to make sure that we have the same amount. So if they're asking if they have two different quantities, so we have 8 packs of hot dogs and 6 hot dog buns, we have different quantities, but we want to know how much or how many we need of the same. So if we're talking about different numbers or different quantities, but we want the same amount, then we would use common multiples. Okay. And here's a different one. So we're going to do the same thing. Zev has 36 pencils and 45 erasers. So we're talking about two different quantities. He wants to use all of the pencils and erasers to make identical packages for his friends. What is the greatest number of package that he can make? So here they want to know we're sharing those quantities. We have 36 pencils and 45 erasers. So if we're dividing up quantities, then we would be using the common factor or the greatest common factor. So here I would use a common factor since the problem is about sharing the quantities of each item in the same number of packages. So because we have different quantities, but they want to know same packages and sharing, then this would be a common factor or greatest common factor. So what I would like you to do is for your lesson, or I want you to go ahead and pause right now. It says there are 46 graders and 24 7th graders in an after-school program. The director wants to create groups where each group has the same number of 6th graders and each group has the same number of 7th graders. What is the greatest number of groups that she can make? I want you to go ahead and pause right now, and I want you to type in if you would be using a common factor or if you would be using a common multiple, and then why. So go ahead and pause right now. So hopefully you said it was common factor because the problem is about sharing the number of students in each grade with the same number of groups. Okay, so we have 40 and 24, which are two different quantities, but they're sharing, so we want the common factor. All right, this last one, you're going to do the same thing. So every time Soraya babysits, she saves $12 of her earnings. Every time Aaron babysits, he saves $9 of his earnings. And after babysitting a number of times, Soraya and Aaron have saved the exact amount of earnings. What is the least possible amount of savings that they could have? So again, think to yourself, if we are looking for splitting two different quantities of items in the same to find the same amount, or if we're equally sharing. So think about those two things. So go ahead and pause, and then when you've completed your answer, hit unpause or hit play, and you can check it. So hopefully we said common multiple because the problem is about when the total amount that each person makes will be the same. So we have two different quantities. We have Soraya $12 and Aaron 9, but we want to know at what point in time are they going to make the same amount of money, okay? And again, make sure that you're completing what I'm completing because you'll be turning this in and you'll be receiving a grade for it. All right, so Emily has 3 bags of different types of beads. She wants to split up the beads into mixed packages to share with her friends. She wants each package to have exactly the same number of each type of bead with no beads left over. So common factors help you think about how to divide or share things equally. And that's what we're doing. We have 3 different quantities of beads and different types. We have spacers in 40 count, round beads in 72, and rectangular in 24 count. Common multiples help you think about how things are different cycles can occur at the same time. We're not talking about a cycle, we're just talking about we have these beads, different amounts, different kinds, and we want to equally split them so that we have none left over. So we've read the problem and we're going to figure out if we're going to use the greatest common factor or the least common multiple, and then what is the greatest number of packages that Emily can assemble. And we're going to describe what the collection of beads will look like. So if we're finding greatest common factor, greatest common multiple, what will the assortment of beads, how many of each will that we have? So we are not talking about something in a cycle, okay? So we're not going to be using that common multiple. We are going to be looking at the greatest common factor. So what I'm going to start with first is I am actually going to do factor trees for all 3 of these. So I have 40, 72, and 24. And I'm going to write all over this and then I'll delete it, but I need to have that visual. So here's my pen. We're going to start off with 40. So my factors of 40 are going to be, I could do 10 and 4. And 10 and 4 are still composite. I can do 2 and 5. 2 is prime, 5 is prime, and then 4 would be 2 and 2. So I'm going to go ahead and I'm going to write down here 2 times 2 times 2 times 5. And I probably should have done them in the same colors, but I didn't. I should have did that in orange. All right, so those are the spacers. So my prime factorization of the spacers are 2 times 2 times 2 times 5. I don't want to worry about using the exponent right now just because I need this to put into the table. But I could rewrite it as 2 to the 3rd power times 5. All right, so let's go ahead and I'll do purple. This time we have the round beads. So I want to do the prime factorization of 72 because it's a 72 count bag. So I'm going to go ahead and start with 2 times 36. 2 is prime, but 36 is not. So I'm going to do 6 times 6 is 36. 6 is prime, so I'm going to do 3 times 2. And then 3 times 2. Okay, 2 is prime, 3 is prime, 3 is prime, and 2 is prime. So I'm going to rewrite this down here as 2 times 2 times 3 times 3. And then I'm going to do my last one, and I'm going to do it in blue because those are my last beads, which are the rectangle beads. So I need the prime factorization of 24. So I can do 4 and 6, and then I can do 2 and 2, 2's prime, 2's prime, and then 6 I have 2 and 3. So my prime factorization of this one will be 2 times 2 times 2 times 3. All right, so I have my factor trees, but now it's very difficult to look at all this. So I'm going to put it in a table so that we can see it. I'm going to do it in red so I can write over top. So at the top, I'm going to go ahead and I'm going to make my table as neat as I can. And I have 3 numbers, so I need 3 rows. So my first one is going to be 40. My second one is 72. And my last one is 24. Okay, now I'm going to go ahead and remember, I'm going to put these, if they match, then I can put them all in there. So let's look at my first one. 40, I have a 2, 72, I have a 2, and 24, I have a 2. So I can go ahead and put 2's in this first one. Okay, so that knocked out here. They have all of that in common. All right, they have a 2, a 2, and a 2. That's in common. So I can make another column with 2's because they all 3 have it in common. Trying to make this as neat as I can. I'm going to cross out, cross out, cross out. Now, 40 has a 2, but we're out of 2's for 72, and 24 has a 2. So I'm going to go ahead and I know that I can put a 2 in 40. 72 doesn't have any more 2's, so I'm going to skip down to 24 because we have a 2 left in 24. Okay, then I have 3's with 24 and 72, and then I have a 5 with 40. So I'm going to go ahead and put a line here, and I'm going to do my 3's. So I have a 72 and a 24 that have a common, so I can put a 3 here and a 3 here. That knocks out that one and that one, but I still have a 3 and 72. So in this next column, I'm only going to put 1 in the 72 because that's what's left. So a 3 will go here. And then I have a 5 left, and the only thing that has a 5 is 40. So I'm only going to put that in 40. So now what we can do is we can look to see where do they have those in common. So that means they have the same number in all 3 rows. So they have a 2 here, a 2 here, and that's it. Okay, so that means that we have a 2 and a 2. So to get the greatest common factor, we multiply those. So 2 times 2 is, actually, I think we were supposed to have another one. I think we missed one. We're supposed to have 3. So this goes here. My mistake. So we should have 2 times 2 times 2. So that means we have an equal of 8. I missed a 2. Sorry, guys. All right, so that means that the greatest number of packages that she can assemble with the same amount of each bead in would be 8 packages. So I'm going to clear my screen so that I can type here. And I'm going to say that Emily can make 8 equal bags of beads. And so now we can figure out how much each has. So if I have 40 and I make 8 equal bags, I could do 40 divided by 8, which would mean that the bags would have 5 spacers, and then, oops, I misspelled that, 5 spacers. And then if I do 72 divided by 8, I'm going to get 9. So there would be 9 round beads, not beans, beads. And then if I take 24 and divide it by 8 because we have 8 equal bags, and I want to figure out how many of those rectangular beads would it be in it, and I would have 3 rectangle beads. Okay, so we can make 8 equal bags because we found our greatest common factor, and we would know that in each bag we'd have 5 spacers, 9 round beads, and 3 rectangle beads, and that means that there would be none left over. We've used all the beads and created the amount of bags of 8. So now we're going to talk about a cyclist. She completes a lap around a track in 12 minutes. So she is cycling on a cycle and she goes around a track. A lap is one time around. So she completes one lap in 12 minutes. A second cyclist completes that same lap around it, but in 18 minutes. So we're talking about 2 different quantities, but we want to know when it's in common where they're going to occur at the same time. So common factors help you think about how to divide or share things, which we're not doing here, but common multiples help you think about how things with different cycles can occur. So this is a different cycle because one person is going around the track in 12 minutes and the other one is going around the track in 18 minutes. So because of that, we are going to use least common multiple. So we're going to find the multiples of these numbers, and then we are going to find the least one to figure out the answer to this. So let me grab my pen real quick. So I have 12 minutes and 18 minutes. So I need to start writing my common multiples of 12 and 18. So I'm going to count by 12s. So 12, 24, 36. I'm just counting by 12s. And then I can do 18 and then 36. But I'm just going to stop right there because I need a number that is common in both of these. Well, I can stop right there because I see 36. Nothing else is in common, but the multiple of 18 and 12 is 36. So there's my answer. Okay, I could, if I continued on both of these, it wouldn't be necessary. I've already found a multiple that is the same. Okay, so there's our answer. So that means if both riders are starting at the same time and maintain their speed in 36 minutes, they will be at the same they will meet at the same spot, which would be at 36 at the same spot at 36 minutes. So the 2 riders they will meet at 36 minutes. So then that means that the first rider, if we look here, this is the first rider, 1 lap, 2 lap, 3 lap, will have made 3 laps. And the second rider will have made, we've got 1, 2 laps. Okay, so that's talking about different numbers or different quantities in a cycle and when they'll meet up. All right, so you have used least common multiple and greatest common factor to solve real world problems in this lesson. Now, from the beginning of the lesson, the getting started activity, you are actually going to do the actual answers. So the first 4 questions that we entered the lesson to, you just had to write if we would find the common factor or the common multiple. So I'm going to do the first one with you. And then you are going to do the last 3 and submit them. So there's 4 total. You are going to do the first, or I'm going to do the first one with you, and then you're going to do the last 3 and then submit them, and I will give you a grade for that. So we're back to those hot dogs. They come in packs of 8 and packs of 6. The least number of hot dogs packs you can buy if you want to have the same number of hot dog buns. So we want to figure out 2 different quantities, but we want the same amount. So I know that I will be utilizing the greatest common factor because we're not talking, or sorry, the least common multiple, because we are talking about in the same cycle. We want to make sure that we have the same number of hot dogs and the same number of buns. So I'm going to go ahead and I'm going to grab my pen and I am going to start the multiples. So I have 8 and I have 6. So I am going to do the first 6 multiples of 8. So I'm going to count by 8 6 times. So I have 16, 24, 32, 40, and 48. Okay. So 1, 2, 3, 4, 5, 6. Now here I'm going to count by 6 8 times. So the first 8 multiples of 6. So 6, 12, 18, 24, 30, 36, 42, and 48. Now I'm going to look to see what my least number is that I have in common. So I don't have a 16, but I have a 24. So right there, that means I'd have to purchase 2 bags of packs of hot dogs and 1, 2, 3 bags of buns to have the same number of hot dogs and the same number of buns. Okay, so that's what I'm going to write here. So I am going to write the least common multiple of 8 and 6 is 24. And we just figured that out. So you would want to buy, remember, 1, 2, 3. So we would want to buy 3 packs of hot dogs and 1, 2, 3, 4 packs of hot dog. All right, so you're going to do the last 3. You're going to do the same thing, just like I did. But you may not be finding common multiple. You might have to do greatest common factor. So this one, I said that the least common multiple, stating that that's what I found, is of 8 and 6 is 24. That was my answer. And I would know that if I had 24 hot dogs and buns, that would be 3 packs of hot dogs and 4 packs of hot dog buns. Okay, so you're going to do this one right here. We're talking about pencils and erasers. And if you need to go back, at the beginning of the lesson, we talked about why and what we would choose, least common multiple or greatest common factor. Remember, if we're dividing something up amongst people, then we're going to use greatest common factor. If we're going to find something in the same cycle or trying to catch up in the same cycle, then that means we're going to use least common multiple. Then you have the 46th graders and 24 7th graders. And the last one is talking about the babysits and the money. And then after that, you're going to, after you've completed everything, there's 11 questions total. You're going to turn it in, and then I will look at it on my end, and I will get it graded and get it into your Google Classroom. All right, guys, I will see you later. And like I said, there is a video in case you need to go back and look at it. If maybe something didn't make sense here, you can go look there, see if maybe they say it a little bit different way. If you have any questions, we do not have a Google Meet today, but you can send me a message. Remember, all of your work is due on Friday.